All right. Good morning, good afternoon, good evening to everyone, and thanks for joining us from around the globe. Welcome to the webinar. My name is Tanmay, and I'm part of the Basecamp developer community team. I'm going to invite Joe, who's the product expert at NuoDB, and he's going to talk about Kubernetes and how Temenos Transact and NuoDB use Kubernetes for automation and scale. There's more to it, and I'm going to hand it over to Joe to take it further. Thank you, Joe. Hand it over to you. Thank you.
Great, thank you very much. And thank you all for joining. It's a pleasure to be here with you today and to moderate today's call. So just a few introductions to how our call logistics and format will work today. We plan a very interactive call. So feel free to post your questions to the QA panel, which you'll notice to the bottom and to the right. I'll be monitoring that today, and we'll be able to answer your questions interactively. Boris will be presenting today. He's our enterprise architect here at NuoDB, and Boris will take us through the call and the slides. We'll also be recording today's presentation, so it will be posted to the Basecamp afterwards. With that, I think we're ready to go ahead and start, Boris. So why don't you go ahead and take it away?
Thank you very much, Joe. And as both Tanmay and Joe mentioned, let's try to make this interactive. Please post questions, and thank you for your time, the time you decided to spend with us. We hope to make this interesting and valuable. The audience is quite diverse, and the subject is very broad. So what we've tried to do is put a little bit of information for everybody, right? If you have advanced knowledge of the topics, you can hopefully take something out of this presentation, or if you're totally novice and you know nothing about Kubernetes and we probably know very little about NoDB, we'll have content for you to take away and some understanding of the subject. So hopefully it's going to be very useful. So in terms of the agenda, quite simple. We'll first give you a little bit of a background on the topics involved. Most of you know, or all of you know, Temenos. We'll tell you a little bit about NoDB and fundamentals of Kubernetes, which are relevant. We'll then show how Kubernetes, NuoDB, and Temenos come together in an actual video recording of a demo, which is we participated in, and it's from the perspective of technology, it's very, very impressive. We'll then go through the Kubernetes concept a little bit more detail to understand how the systems like that operate, and finally we'll talk about the actual deployment that the two companies, Temenos and NuoDB, have been very successful with this environment. So with that, let me move forward. And something that I'm very familiar with is Temenos as a company, but sometimes we're a little bit too close to the metal to see the history, if you will, or direction of the company and where technology is evolving. So Temenos is a very unique company from the perspective of both the depth and comprehensiveness of the business functionality of their platform. So over the years, Temenos, as you can see on the bottom of this particular graph, have been adding more and more business functionality. And in today's world, it's quite often found to be the most functional core banking platform out there, right? Which is clearly a very high bar to jump over. But also what makes Temenos technology to be very successful is its ability as a company to stay very close to technology innovation, right? So every 5 to 10 years, new kinds of technology come along, and Temenos platform is ready to embrace those kind of changes in the most significant, profound way. So if we look back, client server, multi-tier computing, G2E are sort of like the milestones, if you will, if we look in the past that all of us or most of us are familiar with. What's very important is in the last couple of years, there is another architectural refresh that Temenos platform is going through, Transact platform, and that is becoming cloud native. And that's why this particular presentation is, in our minds, is very relevant and important, is because it really takes apart what does it really mean to be cloud native. right? And there are two components here in the red circle that you can probably see. That first very important aspect is containers, right? Containers we'll talk about. It's, it falls under the umbrella of something that people call Kubernetes. We'll show what it is and how it works, but also it's distributed databases, right? And this is another new sort of almost paradigm shift that we'll give you a little bit of information on, but clearly this is just the beginning of discussion. It's a beginning of the process, and Joe, myself, and our other colleagues across Temenos and NoDB will be very happy to stay with you through this journey. But this is the beginning of the journey, we hope, for a lot of people. So with that, this is what Temenos is. Let me tell you a little bit about NoDB because it's a new concept on one hand. On the other hand, it's something that technologists like us are very familiar with. So NoDB is a database, right? So if you, as you know about relational database management systems, they've existed for the past 40, 45 years. Myself, I'm a Oracle architect and developer for many, many years. I love the technology. Relatively speaking, and it's quite often acknowledged, that databases are probably the most useful concept in terms of application out there historically, because they're used everywhere, they're prolific, they're ubiquitous. But something interesting is happening, right? So if you look at the database architecture, RDBS architecture, it's, as I mentioned, it's been designed a long time ago, and it's been designed for application architecture and infrastructure architecture, which is very different than the one we're finding today, right? The databases, what we call traditional databases, are generally referred to as monolithic, right? And the reason for that is because they are confined to a single large computer most of the time. Sometimes you can have other kinds of deployments like Oracle RAC or Oracle Exadata, which take it a little bit further. But nevertheless, the core technology is really designed for this storage-centric monolithic computing. And you can see this picture on the left, and everybody can relate to this. So how is NoDB different? NoDB is a distributed RDBMS. So what this means is that to application, and you can see this couple of application bubbles on the top, the database looks like any other traditional or distributed relational database. It's just SQL. It's just transactions. So you can use JDBC strings, you can use all kinds of drivers. The database is exactly the same. But on the inside, NoDB is a very different beast, right? It is a distributed database. It's comprised of multiple servers which run together, and together they form a single logical database, right? Which can be addressed, again, in a very simple way, just like any other database. So think of this, and we'll come back to this, that when you think about NoDB, it's multiple processes together forming a single logical database. And importantly, you can add more servers, and then database becomes larger, if you will. Larger meaning that it can process more transactions, it has more capacity. But also what's very unique about this, that it's fault tolerant, meaning that components can fail, the infrastructure can fail, parts of the system can fail, but the database services will continue to be delivered, right? So this notion of redundancy, resilience is built into the core database. It's the base architecture. And we'll see that this is very important for this discussion. Also what we'll see, and we'll introduce the concept of containers today, because of this nature of multiple servers working together, this architecture is very easily, and we'll explore this concept in a second, containerized, right? Containers are like very little VMs, which you can start up in multiple places, and they allow you to be more nimble, right? Or your application can be more nimble. It can move around. It can, you can shut things down. It will bring itself up. That is containers, right? So you can almost see already that this type of architecture where you have multiple servers can be easily containerized, okay? So the next interesting concept is this notion of Kubernetes. What is Kubernetes? So I assume that most of us, and I mentioned this term already, familiar with the containers. Containers, again, are just like small VMs, which are much lighter weight and then can be started faster, and they can go away faster, and they enable a different paradigm, if you will, in terms of how applications are put together and how they're managed, the life cycle and how they operate it, right? The life cycle of applications. But let's step back for a minute and really understand why containers, why Kubernetes, and why it's so interesting. And it's really another sort of architectural paradigm shift, if you will. So the concept is very simple. A couple of things you can see on the left side, right? first, let's think about a platform, right? Computers. So over the years, what happened is that computers became smaller, right? So we went from mainframes to large computers, to minis, to micros, to commodity, right? So we today live in a world of commodity. So if you look at the platform, and especially for the cloud platform, it's comprised of commodity computers. Computers are the same. There are more of them. They're generally smaller, and they can be operated at scale, right? And we'll also learn from the companies like Google, like Yahoo, like Microsoft, that that's really the way to get scale. Is not by creating very large computers, but by creating computers, smaller computers, which can work together and together form scalable systems. So platforms are changing. So that's one aspect. Another interesting aspect is that application architecture generally follows the infrastructure. So applications architecture is changing. So most of you probably heard this notion of microservices. So what is microservices? Well, it's taking an application which is monolithic. You have a J2E app, or you have a client server app. And it means breaking it up into multiple individual services, which are much more specific to the kind of business tasks or technical tasks they do, but they all work together. And that's why now an application is generally comprised of multiple microservices. Interestingly enough, that is a direction in which Temenos, Transact, and Infinity are going as well, right? These are microservices-based applications. And Transact is sort of in the beginning of this journey, where today already the T24 and TPH are a collection of services, and the same kind of architecture will continue moving forward. The reason for this is quite also interesting and straightforward. If you imagine that technical companies, technical innovators, I'm going back to Google because that's one of the first companies which innovated in that space the most, needed to be able to produce or deploy new functionality faster than others. So today you look at the companies which compete in e-commerce, in infrastructure, companies like Netflix, companies like Amazon, in terms of commerce sites, right? Google and so forth. Amazingly, scalable, complex infrastructures, but they can release functionality very quickly. So interestingly enough, enterprises and specifically banking started to embrace the same concepts as well, for a very simple reason, right? They have to be able to roll out functionality quicker to their banking users, and because they want to compete with each other. User experience trumps everything, right? So user experience, new functionality, ability to go from concept to production in a very short period of time is critical, and therefore you see Temenos putting out infrastructure and processes around, for instance, Temenos continuous deployment, right? Ability to go from concept to production in a day, right? That's sort of a very high level bar. But that's really what's behind this. This is why people are doing, moving towards microservices, moving towards commodity platforms. And now we're faced with a challenge, right? And the challenge is quite simple. It was easy to operate and develop monolithic applications because there's one of applications or a couple of applications, there is a database and there is a computer or a couple of computers, and you can deploy and you can operate it. But now suddenly applications becomes tens and hundreds of microservices, meaning processes, and they have to be deployed across tens and hundreds and thousands of computers, right? Which could be containers, or it could be something in a cloud or a micro cloud or a private cloud, right? So both applications and computing platforms become much more complex. Well, not complex, but you have many more instances that you need to manage. And reality is such that you cannot do it by hand, right? The operator teams, the DBA teams that were able to manage the complexities of the past cannot really move forward in the same manual way in terms of the operating the applications, operating the databases, operating the infrastructure. And that's the reason why you see this picture on the bottom, which says that there is something in the middle. We still have operators, we have to still have DBAs, but the things they do change dramatically, right? And that's where we need a help of workflow engine, if you will, right? Or specifically in the context of containers, it's referred to container orchestration engine. This is automation which allows us to develop, deploy, and manage applications which are packaged not as monoliths, but as containers, right? And Kubernetes is the framework. Kubernetes is really the engine, the COE, container orchestration engine, which does exactly that, right? So that's the context. So moving to the right side of the slide, what's the purpose, what's the objective of having some kind of infrastructure, management infrastructure like Kubernetes? Well, it's very simple. We want to be able to operate more applications at a lower cost with lower risk. So if you imagine that you have thousands of processes on thousands of machines, the last thing you want to do is to start remapping IP addresses if some sort of a machine goes down and you need to redeploy the application. It's impossible to do. It's impossible to do in real time. It's impossible to do at scale. And that's really what Kubernetes does. So the requirements for Kubernetes is how can we develop, release, and operate software quickly? How can operations be predictable and automated? And how do we do it at scale? So that's really, if you think if somebody brings up Kubernetes, that's what Kubernetes does. It does exactly what I just described, right? Automation at scale. Now, to step back, and one can question, well, we're talking about very serious mission critical systems, core banking, payments, credit cards, a variety of different, the most complex, the most reliable systems in the world. It sounds like Kubernetes is something reasonably new, right? So what's the risk factor? Well, reality is that it may be new to enterprises or newer to enterprises and banking, but it's a very stable, very mature technology. And a quick example here on the bottom, just in terms of history of Kubernetes, right? This is the concept that Google as a company came up with 15 years ago, 15 to 20 years ago, and been practicing ever since, right? And just a fascinating bit of statistics here, which is pretty dated. It goes back 6-7 years. But imagine that Google as a company starts back in 2014, starts 2 billion containers per week. So starts meaning it starts 2 billion, it takes down 2 billion, and there is some, it's operating all the time. So it's roughly 3,000 containers per second going up, 3,000 going down, and probably 20,000 or billions are operating at any given time. That means that the technology is very reliable. It's in a third generation of maturation and ease of use, and therefore it allows us to do things which are very, very interesting. So let's explore it a little bit further. So what is Kubernetes? Any distributed system, and a good thing that comes to mind, or one thing that comes to mind if you're familiar with Hadoop, which is big data processing, is very similar in its structure. You always have something that is called a control plane, and then you have the machines which actually do the work, right? So this is a schematic of how every Kubernetes is clustered, right? And we'll talk about the clusters. Kubernetes cluster is so like a unit of management, if you will, that you're operating a cluster and one can have many clusters, right? And a cluster is a collection of computers, which is sort of self-contained, if you will, right? So you have control part of the cluster. Sometimes it's referred to as a control node, and it has all the machinery which is needed to manage it. You normally don't see it. It creates sort of like this kind of abstract concepts and services that we'll talk about, but its implementation is invisible and really not important for the users of Kubernetes clusters. And then we have what we call worker nodes. So worker nodes, the couple of concepts here which are very important. We'll talk about nodes. Nodes are equivalent, you can make a connection in your mind, of computers. So node is a computer, right? You can have different nodes of different sizes, but this is a virtual machine, or it could be a physical computer. It's something that actually can execute things, right? We then have, within worker nodes, a couple of concepts which are key, and we'll talk about those. There is a concept of container. Container is actually, as I mentioned before, it's a small virtual machine, right? It's a unit of management, and it's a unit of packaging of your, for your process, right, if you will. So what Kubernetes does, it takes this notion of container, as you can see on the bottom, and it wraps it up into a higher level entity or object, if you will, which is called a pod, right? Pod is container plus a little bit of functionality, which is used for management. And normally pod may have multiple containers, but usually has just one, right? So the two important concepts from here, which we'll use over and over again, are a node, which is, think of a computer, and a pod, which is really a wrapper around a container. We can refer to pod as a container more or less, right? So these are two important concepts. Now, put it in a sort of like bigger frame. How, as a user of this infrastructure, what do I see? Why is this important? Well, imagine that you are, for instance, you open a browser and you're connecting to a web server. As far as how a browser accesses the cluster, the services, it's very simple. It's a URL, right? Browser navigates to the URL, and then things happen, right? Within this infrastructure, Kubernetes is responsible for taking this URL and connecting it to the right pod, to the right service, to the right process, if you will. And if things happen, like for instance, the machine dies or the process dies, or you have too many requests and it needs to spin more processes, all of that is managed by Kubernetes. But as far as user is concerned, it's very simple. You can see this user bubble on the right side. It's just give me some reference, and to me, it just means that I'm accessing a process which is managed. It's a managed process. But other than that, the view of Kubernetes is very simple. It's the way to coordinate and manage resources. And resources are processes, right? Everything at the end in our world comes down to the process. And that's what the system does. So enough detail on that. Let me jump into the actual, the best way to talk about something is to actually demonstrate how it works. And then we can sort of try to ponder about what goes into making it work. So think of the system, right? We have on the left side a Transact deployment. So you can see a couple of Transact bubbles, right? So this is Temenos infrastructure, blue bubbles, and they connect to a database. And you can see database is in green, and it's comprised of two types of processes. It's really not that relevant at this point in time what they are, but those green bubbles form a database, and that's a NuoDB database. What's important about this picture is that we have two independent areas in which both Transact and NuoDB are deployed in. On the left side, it's on premises, it's a data center. And on the right side, it's a cloud. In this case, it's a Google Cloud, right? And we have, you can see a couple of instances of Transact on the left side, a couple of instances of Transact on the right side. And then we have the green bubbles, which connected with a line. So for all of us in the audience, we'll know that there are certain processes that are stateless, right? Meaning that they can do processing, but they don't have data. And then you have databases. Databases are not generally, but almost exclusively designed to manage data. And that's a very difficult thing, right? So in this case, Transact is stateless, and we can start many processes. And NuoDB is a stateful database which manages data. Well, unique thing about this picture, it manages data across all of those environments, both of those environments, across cloud and on-prem, and therefore Transact can be active across these two environments, right? So for technologists, it's really exciting. Imagine that you have Transact, which spans cloud and on-prem data centers and can be active in both. And the reasons for this excitement is because it gives us so much more flexibility. One of them is if you're in a cloud, you can be elastic, right? You can allocate resources quickly. The second interesting aspect that the system becomes failure resilient, right? If something fails, if one data center fails, you still have the other one which operates. So this is a very simple diagram of the demo we're going to see in a minute. But effectively, the demo does the following. You can see that on the top, there is JMeter. JMeter is open source infrastructure which can push messages. In this case, it pushes OSF messages to a load balancer, which goes between message queues for on-prem and cloud sides of the system. And it just floods the system with requests effectively. And then take T24, Transact, and NoDB process the requests. And that's how the system operates. So let's move to the actual demo, but keep in mind this picture that we've just seen. The demo will have a dashboard. It's a short demo, it's less than 4 minutes, but it will have a dashboard. In this dashboard, let me just walk through it so when it comes up, you can understand where things are happening and what is happening, right? So we will have here on the top, the view of the message queues, right? So that's those messages, OSF messages from JMeter coming here. And you can see as the queue grows, what it means is that system falls behind, it's under the load. There is a number of messages that cannot process yet. So this top view is messages in a queue. Then we have two sides. On the left, we have on-prem, and on the right, we have cloud. And we have a couple of gauges here, one of which is, this is Transact CPU, right? And we can see that, for instance, there are 2 Transact instances or 3, and on the right side in the cloud, there are many Transact instances which are running. We're tracking their CPU. Similarly, the CPUs for NoDB, you can see here on the left side and also in the cloud. And also we have transactions, right? So we're also recording how many transactions are actually written to the disk by the database by T24. So a couple of things to keep in mind here. The way that the demo is structured is that the system is running, we're pumping in messages, and then at some point in time, we actually kill the on-premises side of the system. So you can see that there is an interruption on the left side, on-premises is not working, while the right side continues to operate and process the transactions. So that's really the point of the demo, is to illustrate that the system is self-managing, it's resilient, and it exists across multiple environments. But we will take a slightly different message from this demo. What we wanted to show you is very simple, that a system of this complexity, imagine that you have literally 50 processes involved in how the system operates. What happens when the system components fail? Small components or collection of components like the whole data center. What happens when you recover? So the point of this demo that we'll see in the next minute is that all of this complexity is completely touchless. Think about self-driving car, right? This is what we're looking at. We're looking at the self-driving Transact Kubernetes NoDB installation, which manages itself. Not only it knows how to scale and contract, but it also knows how to behave during failure and how to repair itself. And I can imagine, if you imagine that you're doing it by hand, it wouldn't be easy. So let me switch very quickly to the demo. Again, it's less than 4 minutes, and let's see what happens here.
We understand that retail banks depend on Temenos apps to process essential banking transactions, from deposits and withdrawals to critical loans. In this demo, our fictional bank has deployed their Transact core banking app running on NuoDB, distributed database, on Anthos Google Kubernetes engine, or GKE, giving them the flexibility to run production workloads on premises in their own data center, while also having a secondary site on Google Cloud, set up for bursting to handle unforeseen surges in core banking transactions, failover to the cloud for disaster recovery, and auto-scaling back down to maintain business as usual. This full demo of Done Live spans 1 hour, so keep in mind that we have edited for time. Let's take a quick tour of the dashboard. Starting on the upper left, you can see the active MQ message queue count. Going down the left side, you see the Transact and NuoDB CPU and NuoDB commits on-prem and in the cloud. We're using JMeter to load the transactions into ActiveMQ. So on the upper right chart, we present the number of transactions per second. In this demo, the system on-prem is built to handle a maximum normal load of 20 transactions per second. Going down the right side, see the 2 GKE nodes ready to go, with the ability to auto-scale up to 5 nodes. Transact on-prem is set to scale up to 3 replicas. After that, to support additional load, Transact is set to scale up to 19 replicas in Google Cloud GKE. And on the bottom, we show how NuoDB transaction engine is also set to scale up to 3 replicas. As we've been going through the tour, you can see that with the exception of a brief spike, the system has been processing a fairly steady and quote-unquote normal load of about 13 transactions per second. In the active MQ chart, you can also see that for the most part, transactions are being processed right away, so messages are not queuing up. All looks good so far. We've started fast forwarding, so you can see how Google Cloud can help with a sudden surge up to 150 transactions per second and beyond. GKE Transact replicas scale to 19, and GKE nodes auto-scale up to 5. NuoDB transaction engine will also scale up to 2, with the CPU utilization rate exceeding the target. Messages are building in the queue. We fast forward more to show how the system is coping well with the increasingly heavy load, and that activity in the NuoDB transaction engine replicas is converging. Finally, we reach peak activity of about 250 transactions per second. Messages really start accumulating as this is too much for the system to handle. Now we simulate a worst case scenario in this demo, failure on premises at the maximum load. In this DR scenario, cloud is just about managing the messages while the on-prem site is down. After about 470 seconds of downtime, the on-prem data center is operational again. Next, we'll show how Transact on Google Cloud is set to automatically scale back down when transaction loads return to normal. Messages have gone down to 0, transaction engine activity converges, and Transact replicas in Google Cloud scale back to 1, and NuoDB transaction engine in the cloud also scales down to 2. The system in the cloud continues to scale down. NuoDB transaction engine replicas are now down to a minimum. And the GKE nodes are starting to scale back down from 5 to 2 as well. In conclusion, this demo showed how Transact can be set up to burst seamlessly from on-premises to Google Cloud to handle unforeseen spikes in load, how it can fail over to the cloud, and also auto-scale back down again to maintain business as usual. Thank you for watching.
Great. So the takeaway, right? It's the lady who is narrating the demo is very sort of consistent and not excited per se, right? But just think about this, what we just saw, and not even what we saw, but just the capabilities that we have to be able to manage a single installation, right? A single logical installation of T24 across environments of such vast complexity that it can properly size itself depending on a load without human interaction. It can understand how to act during the failures, and it can recover itself, right? So this is really, if you'll think about this, this is the future of how the systems will operate and have to operate because they're becoming more complex, but also it's a part of the Temenos future because that's where complexity and comprehensiveness of this sort of cloud native systems is, right? And we'll explore it a little bit further. So I looked at my watch, and I usually love to dive into all the details, but we're running short on time, and we also wanted to actually answer some questions and present more information. So I'll go very quickly. A couple of concepts that about the Kubernetes, which are pretty interesting, right? So how do you make this kind of systems, Kubernetes systems, to be both repeatable and easily, and you can easily configure them and model them. So there are a couple of concepts which are key, which we'll touch on. There are many more that Kubernetes provides, but these are interesting ones. So first of all, Kubernetes allows us to organize our processes, right? Processes are containers or pods to have different behavior. And they have these declarative structures that they refer to as controllers, right? And here's an example of some of the controllers. And just to give you a flavor for what they do. So for instance, you can say that my process, my pod, is a replica set, and Kubernetes will maintain, for instance, we say in our replica set, we want to have 3 instances of pods all the time. So Kubernetes is then responsible for maintaining, you can see replica set, blue pods. We'll make sure that there are always 3 blue pods running on a cluster at any given time. On the flip side, we can have a different desire for how the processes are deployed and maintained. We can describe them as a daemon set, right? If it's a daemon set, the pods will be started exactly once on every one of the nodes, right? Nodes are actual computers. So you can see that by declaring certain constructs to be of a certain type, we can derive certain behavior, right? And there are other types of controllers, for instance, jobs, cron jobs, that, naturally you would understand what those means, right? Things which are started in certain periods of time and they don't require human interaction and so forth, right? So these are examples of us describing pods, processes, in a way that has inherent behavior that is managed by Kubernetes. So that's one of the examples of this high-level behavior. The other very important concept in the distributed system is networking, right? And we have 2 kinds of elements in our system. We have nodes, which are computers, and we have pods, which are effectively, containers or virtual machines. and they naturally have two different networking mechanisms, right? One is native between the nodes, and one is virtual, which is simulated, emulated on the top of that, which is pods. So how do you bridge those two together? And Kubernetes comes up with several, again, declarative structures which enable us to bridge this difference, right? So for instance, there are things called node ports. They bridge they abstract the notion of the nodes. And then there are things like cluster IPs, which connect pods, right? So these are networking abstractions. Then finally, another element which is critical for systems like Temenos, Transact, and NuoDB is the storage. You have to store data. These are transactional systems. And you imagine that Kubernetes can be deployed in a variety of different environments. So how do you do this? So Kubernetes comes up with the notion of storage classes, which you can define yourself. You can tie them to the specific implementation. So for instance, you may be in Amazon and you can use EBS, or you can be in Google and you can use Google Storage, or you can be on-prem and you can use SSDs. So you define your different storage classes, right? And then you describe your system in terms of those classes. And those within a system, you can define just very simple steps. The administrators can define persistent volumes, effectively disks available for people to grab, for processes to grab. Those are called persistent volumes, PVs. And then when a process comes in, when a pod comes in, and pod says, I'd like to have some storage, right? It just grabs one of the PVs, persistent volumes, and therefore it claims it, right? So there are PVCs. So these things can be pre-configured, or they can be done totally dynamically. So again, these are just a couple of highlights to illustrate that Kubernetes is a declarative system, which is very portable, which is very consistent in terms of how it's described, and therefore it allows you to customize the behavior of your applications in a very consistent, repeatable manner across varieties of different platforms. So that's great. How do you configure the systems? And configuration is quite simple. There is a notion of YAML files, right? So declarative systems, what you normally do, you declare how constructs are structured and related to each other, and then you customize those declarations with all kinds of properties. And that's exactly how Kubernetes works. It has the notion of a YAML files, right, which contains those settings. Those settings are very well structured. They may appear to begin with to be somewhat overwhelming, but they're not, right? There is a very specific structure to how they're set up. If you don't want to customize anything, you don't have to. There are all defaults which come with the system, but then you can start incrementally override certain elements of it, and therefore that's how the system becomes customized. The next question is, how do you manage all this YAML file? In a complex system, you may have hundreds and thousands of components with probably tens of thousands of different settings. And that's where we have other types of systems which manage this kind of release and operational process in a very predictable manner, right? So one of those kind of approaches is called Helm charts. So YAML files are organized in Helm charts, which are hierarchical structures of those YAML files. And they are managed in repositories, and they can be released with the development process by updating certain individual values. And they go through the release process, deployment process, and then finally going into the production process. The goal is, how do you automate it? How do you make this process predictable and reliable? And that's what Kubernetes does. And it has a couple of facilities within this, like Helm and Helm charts, to automate that process. So another quick picture, conceptually, what does it mean, right? So imagine that you have a very simple setup where you have a cloud, let's say it's Amazon Web Services Cloud, and you have several availability zones in which you allocate a number of nodes. You can see the nodes that are available within this cluster, right? We have nodes and we have cluster. The power of Kubernetes, that if you're deploying your system in this environment, you don't have to do anything. You just say, I want to have a system with 2 database servers and 2 Temenos Transact application servers and 2 Temenos web servers, right? Web application servers. And the system balances itself out. It deploys itself in the topology that is given, and it's stable in this topology. Now, what we see in a demo as an example of this is if one of this availability zone becomes unavailable, what happens? Well, the system rebalances itself. You don't have to interfere with it. It's all done automatically. It's a self-driving car. Keep in mind, it's like a self-driving car. That's what these complex systems behave like. And this is an example of how something would be deployed. And it gives you hopefully a little bit of a flavor for these types of environments. So finally, what does Transact and NuoDB mean when it runs within Kubernetes? In our practice, as we work with organizations around the globe, people are loving it. And they're loving it for a very simple reason. There is operational simplicity. Just for some of you who've been skilled in deploying T24 in a VM environment over the years, imagine that you can deploy entire T24 infrastructure, all the queues, all the servers, a database, with everything around it, with a single button click in 10 minutes, right? That's what we can do here, right? That's what our customers are doing today. So you can spin up production environments, you can spin up integration environments, you can spin up development environments in a matter of minutes, right? With one click. You can operate those environments in a self-driving manner where you don't have to interfere with them. The system knows where it is, what it does, right? And all you have to do is just monitor it. And if something happens, you have ability to go back and analyze what happened and fix it. But generally, the normal operation is fully automated. And as I mentioned before, one of the goals of this is, what is the business benefit? Well, the business benefit that you have continuous integration deployment. So this bullet on the bottom, right? Temenos continuous deployment allows you, and that's sort of like a tagline, if you will, but that's what people aspire to: develop, test, and release in one day. Imagine then if business user tells you, I need to have this capability, how fast can you do it? Imagine if you can say, well, I can deploy it in production one day, right? Not every bank will want to do it, but over the years, as it becomes more and more established practice, that's really the goal. So with all of that, it's fantastic. The theory is great, but practice is the most important thing. So a quick example, we have a number of engagements where customers are starting to work in Kubernetes, and Joe will take a few minutes later on, give us a little bit of a flavor for what kind of Kubernetes distributions are available. But in this case, a bank is deployed across, and this is a neat thing about this, and very similar to the demo we've seen a few minutes ago, that this particular bank is deployed across two clouds, across Google Cloud and AWS. As a matter of fact, we'll see in a minute, actually it's deployed across three clouds, Google Cloud, AWS, and Azure, right? Active. So all clouds are active. If one cloud provider goes out, the service goes out, which happens rarely, but it happens, the bank is still operational. And this is becoming more or less a regulator requirement where cloud banking or banking in a public cloud becomes acceptable. This is one of the requirements to be able to minimize or concentration of risk, if you will, in such a way that if one cloud is not available, the system will be able to operate. So that's an example of the system. Just a little bit about this particular organization we've been working with, which deployed this. It's an experienced Kubernetes shop, right? You can see on the bottom that they've already been working with Kubernetes before. They embraced this particular stack from Temenos. They do have a number of applications already deployed, not just core banking. You can see here that they have roughly, they gave us the stats of 70 applications, 700 containers, many more by now. And they deployed it on something called Rancher Kubernetes, right? There are many flavors of Kubernetes. Rancher happens to be open source Kubernetes, right? It's a very powerful system. It has different trade-offs between something like Rancher, something that comes from Google, like Anthos, or something that comes from Red Hat, like OpenShift. There are different like trade-offs and benefits, if you will. But it's a very powerful, Rancher is a very powerful environment. A little bit more information about this deployment. It's, as I mentioned, it's 3 clouds, right? It's a very small deployment to start with, but now it's expanding. Just a few nodes per each individual availability zone in those. Networking is important. This is sort of a bill of materials, if you will, which is used in that particular deployment. As you can see, it's both Temenos and NoDB, Transact and NuoDB exist, and Kubernetes exist above the infrastructure, but sometimes infrastructure is very important. So all of this is a well-known technology and can be brought to work in all of those different combinations to deliver this kind of active core banking across multiple environments that can operate, in a very simple way. A little bit more information on how the system is constructed, the bits which go into the making it both deployed and have day one and day two operations is Terraform is being used initially to deploy all engines and servers and nodes. And then there is something called Argo CD that particular bank is using, which is used to actually, remember we've talked about Helm charts. So Argo CD is an environment which is a repository for Helm charts, which can very effectively manage the release process, and it has all interesting capabilities where the charts may be modified in production and they updated in the repo in the other way around, right? So a very powerful environment. So with that, we still have a few minutes left, but just to summarize really the intent of everything we've talked about, right? First of all, Transact platform is fundamentally changing. And this cloud native release, which is R19, R20, R21, and all the releases, or at least until the new generation of technology comes along, right? All the releases from this are going to be cloud native. What this means that the primary way to deploy them is in Kubernetes, right? Across all of these different environments, across on-prem, right? Let's not forget that Kubernetes work in the same way in on-prem environment, in a data center, physical data center, as well as in the cloud, right? So the notion of Transact being able to deploy across those environments, this is fundamental. It's not going away. That's where people have to be able to start taking advantage of that. The second important point of this presentation is that NoDB is a database, which is an integral component of this platform, of this stack, which enables banks to take full advantage of Kubernetes capabilities, right? There is a single stack which manages both T24 and NoDB from the single control plane. And that's what makes this whole environment to be self-driving, if you will. So these are high-level messages. In terms of continuing these discussions, couple of thoughts. We'll have a few minutes now. If you have questions between Joe and I, we should be able to answer them. But also, we're pointing you to the Basecamp forum area, where we're together with our Temenos colleagues, NoDB and Temenos and other developer colleagues of yours will be contributing content and talking about subjects. So please let this session today be sort of like a starting point for a discussion, for a journey. And it's a very exciting journey, and we're very happy that we're going to be there with you all the way. Joe, let me stop here. Any questions at this point in time?
Boris, thank you for taking us through the presentation. That was excellent information. Yes, we have been receiving questions all along, and I've been answering them in the chat. So I think we are good there on questions. Some of the general questions, I think, are around, how are the products, both Temenos and NuoDB, deployed in Kubernetes, and we've been talking about both Helm charts as well as for more complex environments in Temenos using custom YAML files. I should also mention that for ease of evaluation or demonstration, or to get your hands on it, both Temenos and NuoDB have operators. These operators are more single click and easy deployment. So that is another option that is available. And for NuoDB, to give it a try, that operator is available right up on our website. If you just click on the Try NuoDB Now, you will be pointed to that operator.
Joe, maybe what would be useful for folks who are not that familiar with different distributions, maybe you can spend a minute describing what are the different distributions and how are they similar and dissimilar from each other?
Sure. Yeah, so the distributions themselves, right? Kubernetes comes in lots of different flavors that can match certain requirements. So yeah, let's just cover some of them quickly. So Google, for example, on the Google Cloud, Google offers both an on-prem and a public cloud version. So their on-prem version is Anthos, and then the Google Cloud is running the GKE, the Google's Kubernetes engine. And what's nice, what Google has done is that it's really GKE that's running for both. So when you're in either a Google Anthos on-prem environment or the public cloud, you have that same look and feel. It's the same Google Kubernetes engine dashboard, and you're really managing it all from the Google Cloud Platform, which is fantastic. It's visual monitoring and all of it's available. Each one of them has their similar flavor. Red Hat has their OpenShift. It is it also extends. You can run it on-prem or in any cloud vendor's platform. So it is a full solution. Both that I've mentioned support bursting from like an on-prem environment into the cloud, much like our demo had demonstrated for us earlier. And then as well, of course, Amazon has their their EKS, which is their version of Kubernetes, and Azure has theirs, AKS, the Azure Kubernetes services. They're all very similar. What is nice about the Temenos and NuoDB solution, when you are deploying either in a single cluster or a multi-cluster, you get to choose. You could deploy a multi-cluster typically across a multi-cloud of different vendor types. And that is frequently an advantage, right? You can have your primary running on one, for example, maybe the Google Cloud Platform, and then your second cluster, which by the way, both are active, and the second could be running in Amazon or Azure. And should a cluster go down, or one region go down, then the other is going to take over. And that's really a lot of the benefits we're seeing in moving to this cloud native computing is this, concept around the continuous availability deployed up into the cloud environments and as well on-prem. So a lot of it is, it's deploying, where you want and when you want. And how you want. Kubernetes and cloud native computing is very flexible, and that's some of the great promise that we can all go ahead and start working to deploy now.
That's great. So then just initial comment around what Joe described is that Temenos certifies certain stacks, if you will, or distributions. So Google Anthos and GKE are certified. It's a certified stack. OpenShift is a certified stack. Rancher, which is an open source version, is a certified stack. So there's a number of certified stacks, but generally the Kubernetes foundation is the same. It all is derived from the same code base, which is initially was developed by Google and then open source on for the benefit of everybody else, right? And now, effectively, just like in other software environments and markets, people take the open source software like Java, right, and start developing it. Distributions are very much additional value on top of the baseline Kubernetes, and that's how this sort of like ecosystem works. And Transact, Infinity, and NoDB are all Kubernetes enabled, right? We're here talking about Transact and NuoDB specifically, but the same is true for Infinity. But that's what makes the whole process to be very repeatable, very portable. But going back to the beginning of this session, right? The reason why Kubernetes is so fundamental to all of this is because with these new architectures, the complexity of managing it without Kubernetes become untenable, right? So Kubernetes is the way you manage cloud native architectures, and that's what Temenos has done, and that's why it sort of aligned itself with a modern database, which is NoDB, right? Still Transact works with Oracle, it works with SQL Server, but NoDB is the recommended database, if you will, strategically, because it's a modern database and it supports cloud native capabilities. So with that, we're right up the hour. I don't know if Tane, you want to, any concluding comments? If we're good, then we hope to see you on the Basecamp forum, and keep those questions coming. And if you have any kind of design sessions or anything like that, Joe, myself, and our colleagues are open to working together on this.
Sure, Boris, thank you. There are two more questions in the Q&A panel. Would you like to answer it now, or we can take it up later?
Yeah, let's see if we can answer.
Yeah, I actually, due to the short time we had left, I typed a very quick answer with regard to the NuoDB database and supporting only Temenos. NuoDB works extremely well with Temenos. We're tightly integrated and partners, but the NuoDB database itself is a distributed SQL database that has been around for a long time. It works with many SQL applications and supports many driver options that allow you to write your SQL applications or allow your existing SQL applications to connect to a NuoDB SQL database and run ANSI standard SQL. It's a fully ACID compliant SQL relational database system. So, think much like when Boris mentioned earlier, Oracle and SQL Server and Postgres and MySQL. NuoDB is another SQL database. We just happen to be leading in this cloud native space because of the architecture that Boris described. We work very well in distributed environments, and of course work very well with Temenos because of that.
All right, great. I think with that, we've answered all the questions. I once again thank you so much, Boris and Joe, for this session, and it was indeed good, with a lot of examples and the demos that you have shown. I'm sure the audience today found it very valuable. I want to also thank the entire audience today for joining the session. As I said in the beginning, we have recorded this webinar and it will be available on Basecamp as a resource, so you can listen to it again, or you can share it with your friends or colleagues in case if they missed it today. If you have more questions about Kubernetes, Temenos, the Basecamp forum is available. You can post your questions over there. We have a very active community on Basecamp, and we will answer your questions over there. We do regular webinars like this. So if you have any ideas that you want to share with us, any next webinar you want to listen on any particular topic, do feel free to share that with us, and we'll make sure that we have experts on those topics, and we'll arrange webinars according to that. Also visit the Basecamp events page, where you will see the recording as well as previous webinars that we've done so far. The recording of all the webinars are available under the events page. Plus, what's coming up, the new webinars are also available listed over there. So make sure you visit the events page to register for the new webinars as well as see the ones that we've done so far. Thank you so much, all of you. I hope to see you again in the next webinar. Thank you for your time. Take care. Bye-bye.